there, pre-calcers. Shinners here. We are going to be talking about geometric sequences today. So I'll just start by giving you my favorite geometric sequence. I don't know why. I like it because it starts with 2 and I'm multiplying by 2. And I like that. So just a little refresher here if you forgot. A geometric sequence is a sequence of numbers that have a common ratio. And you might also hear me call a common ratio a multiplier. So same kind of thing, right? What am I multiplying by? And so really what we're looking for here is if I divide any term with the term that comes before it, the ratio has to be the same. So 4 divided by 2 gives me 2. 8 divided by 4 gives me 2. 16 divided by 8 gives me 2. So we really are looking for that consistency, right? For it to be geometric. Oh, someone's calling me, but don't worry, I won't answer. Our common ratio here is 2. Good stuff, good stuff. But what we really want to see here is, how do I get to the next term and maybe even the 100th term? So that's when an explicit equation really becomes helpful. So let's say, 2 is obviously my first term. Let's say I wanted to find the 5th term. So I would start with the first term, and how many times do I have to multiply by 2 to get there? Count them up. 1, 2, 3, 4. So I take my first term and I multiply the ratio 4 times. So that's to get to the 5th term, right? So if I'm at the first term and I want to get to the 5th term, I've got to multiply 4 spaces to get there. So that example was just to show you how this explicit equation is created. So I start with my first term and I multiply that ratio n minus 1 times, okay? And we'll see more of that in just a bit. To start with today, we're just going to get warmed up. I give you 2 geometric sequences and you're just going to give me the first 4 terms here. And then we're going to investigate what is that common ratio. So just start by plugging in 1, 2, 3, and 4 here. So you'll see that this sequence is oscillating, meaning it goes negative, positive, negative, positive. So that tells me that ratio is going to be negative since it's changing like that. So here's what I came up with. To find the common ratio, you might just kind of eyeball it and say, hey, looks like we're multiplying by -5 each time. You also can take out your TI-84 or any calculator really, and you're going to just take any term and divide it with the term that comes directly before it. So the big thing here is it's a common ratio. So you should be able to do this with any 2 terms that are directly next to each other, and you'll get that same ratio. And it is -5 in this case. Let's try the next one here. So this one is a fraction, but don't be afraid. So 5/2 to the first term would just be 5/2. And then I'm going to square it. So 5 times 5 gives me 25. 2 times 2 gives me 2. So we see that this one is not oscillating. So that means my ratio is going to just be positive. 5 times 5 times 5 times 5 is 625. 2 times 2 times 2 times 2 is 16. And so again, you might be able to eyeball, hey, Ms. Shinners, the numerators are being multiplied by 5 and the denominator is being multiplied by 2. But if you didn't see that, you also can pop over to your calculator device and make sure you use lots of parentheses with these fractions, because otherwise, as we know, our calculators aren't always experts at the order of ops. But you can see using that same, dividing strategy. We do 25 divided by 4, divided by 5, divided by 2, and we get 2.5 for the ratio, which is equivalent to 5 halves. So that's kind of a little warm up here just to get us thinking about geometric sequences. Let's build some equations here. So I give you the first term and the ratio. So that would be the equation. I'm just plugging and chugging there. And now I'm going to find the sixth term. So for the sixth term, I'm just going to plug in 6 in for n. And I might want to just plop that right in here. So let's do -2 in parentheses. 4 to the 6 minus 1 would be 5. And I get -2048. And I really like notation. So a sub 6, that just means the sixth term. All right, let's try that over here. So a sub n equals my first term times my ratio to the n minus 1. And so we're just going to plug in 6 in for n and plop that into your calculator. -1/3. Use good parentheses here. Oops, I just cleared it. Come on, Shinners. What are you doing? To the 5th power. Ew, that looks so ugly. You could give me the decimal, but I'm kind of a fraction queen. I like fractions better. And it really just becomes 3 to the 5th power in that denominator. Excuse me. So I get -1 over 243 for the sixth term. All righty. Let's try example 3. So find the indicated term in each geometric sequence. So first, in order to find the 8th term, I'm going to want to find my explicit equation. So that's just the first term times the ratio, which appears to be 3 to the n minus 1 power. And so to find that 8th term, I plug in 8 for n. So it just becomes 3 to the 7th power. And I get 2,187. Alrighty, we've got another sequence over here. It looks like my first term is -1. And it looks like my ratio is going to be a -2. So you can always eyeball it, or you can just take any term and divide it by the term that comes directly before it. And you'll see in that case, we get a ratio of -2. And so there's my explicit equation. I'm going to plug in 10 for n. Don't lose any of your negatives here. And I get 512 for my 10th term. Cool beans? Alrighty, let's do some example 4. So this is going to be the trickiest one here, but not too bad, I promise. So I'm going to give you a term or maybe a ratio, and we've got to fill in the rest. So it looks like here, I like to make a table. I love tables. So here are my n's, here are my a sub n. So it looks like my second term is 7 and my ratio is 1/3. So that means I'm multiplying by 1/3 to go down. And so what would have to come before? So to find that a sub 1. So if I'm multiplying by 1/3 to go backwards, to go up, I would divide by 1/3. Which is the same thing as multiplying by 3. So we could do 7 divided by 1/3. It also coincidentally is just 7 times 3. It's just going to be 21, right? Well, that makes sense because 21 times 1/3 would give me that 7. So my first term is 21. My ratio is 1/3. So I can build my explicit equation there. And then to find my 9th term, I'm just going to plug in 9 for n, excuse me there. So we'll just do 21 times 1/3 to the n minus 1, which would be an 8, correct? So I get that kind of icky decimal. We can turn it into a fraction. I like it better that way. So I get the 9th term is 7 over 2,187. If you like it as a decimal, it would be 0.0032 just about. Alrighty. So the little tricky part is kind of working backwards to get to that first term here, folks. So just think, reverse it, undo it, right, to go backwards, okay? So let's see what's going on here. So I give you a 3rd and a 6th term. So 1 over 81, and then I've got 1/3 over there for the 3rd term here. So in order to figure out my first term, I really got to figure out what the heck is my ratio. So I might do 1/3 times how many ratios to get to 1/81st. So let's do 1, 2, 3 equals 1 over 81. And some of you guys might already be thinking, isn't the ratio going to be 1/3? Think about 3 times, what number 3 times is 81? So I know some of you guys are really good at that mental math. But if you're not, that's okay. We can solve this equation here. So we'll do 1 divided by 81, and then we'll times that by 3. So let me show you what I'm doing here. Get rid of that 3 over there. So I'm going to multiply 1 over 81 times 3. And then I'm going to cube root that to figure out what my R is. So math, cube root what I just did there. And I get 0.33, which is 1/3 as a fraction. So what I did there, I multiplied both sides by 3, and then I took the cube root, and I get a ratio of 1/3. And so what would have to come before it then? Opposite of 1/3 would be multiplying by 3 to go up. Then obviously this is 1/9, and this would be 1/27 if you just multiply by 1/3. Okay, so my first term here is 3. So that gives me an explicit formula there. And then to find my 9th term, I'm going to plug in 9 for n. Plug that in over here. And 9 minus 1 is 8. Ooh, that's a very small number. You might want to put that into a fraction. And we get 1 over 2,187, which makes sense, right? Because in both cases, I'm taking 3 to the 8th power to get my denominator. So that's why you see that number popping up again. Alrighty, folks, that's what I've got for you. Make sure you're watching Mr. Gibbons videos as well to make sure you're getting the practice in. I think the trickiest part here is sometimes having to do a little backwards thinking here to get missing ratios or missing first terms. So make sure to email myself or Mr. Gibbon